Greetings friends. In my last video I showed basically a walkthrough of my setup from idea to prototype. I'm now going to show my RF tools. They are very simple RF tools which I advise anyone in electronics to pick up. Okay, we'll start off with SMA antenna, which can be set up the length, and one can set up the length of the of the antenna, so it covers quite a large bandwidth. Okay. My next tool down the line is a tool called the N1201SA. Just going to switch it on. Okay, this is my N1201. My N1201 I use for tuning antennas. One can see I'm showing now SWR of my antenna. Tells me the impedance of my antenna, tells me the insertion drop of my antenna. Very simple $150 tool. Okay, let me switch this off. Okay, switched off. Next down the line, I have a blue screen at the back, so you can't really see it. This is a RTL. This is a STR RTL dongle. STR RTL dongle has got a 2 meg bandwidth. It's a software-defined radio. Very well known, very worthwhile having this device. Covers from about 30 megahertz up to 1.7 gigs. Okay, if the RTL STR was from 1.7 gigs down to about 30 megs, this is its big brother. It's called a Hack RF1. A Hack RF1 is 20 megahertz bandwidth on 8-bit A2Ds. I'm going to make a video on what is an STR and how an STR replaces a lot of custom hardware which one would have used in the years gone by. Those are my basic RF tools. I don't have a full spectrum analyzer. I use these tools as my spectrum analyzer. Okay. As one knows, I am relatively involved with TTN Modien. Basically, a TTN Modien is me, no one else. Okay. Now, there's very little interest in Israel on the technology which is called LoRa. Interests me, but a lot of people are just interested in whatever they can sell, whatever they can do an exit, anything that has got too much burden and it's not going to bring you an exit, and it's not a shiny exit, no one's overly interested in it. Everyone will talk about 5G and narrowband IoT. No one's going to speak about LoRa. LoRaWAN, unless you have a real project. And in Israel, very few people have real projects. They're all ideas for exit. Slicha labitui, khartabuna. Okay. As I started off talking about the two products that I have, which are STR, which are software defined radios. I'm now jumping to a project which I'm doing at this point in time, which is basically a small board based around STM32 and LR1110. Okay. Now, an LR1110 is a LoRa transceiver, but it's a LoRa transceiver which is a full software-defined radio. It's a full SDR. So, why is this different from Manishtana Alayla? Why is this chip different from all other LoRa receivers? And the reason being is because it is a software-defined radio, it has three functionalities. All three functionalities are geo-positioning functionalities. One, LoRaWAN has the ability to geo-position by time of arrival at 3 gateways. So one can pinpoint the position using time of arrival at gateways. Okay. Wi-Fi networks are mapped, whether one likes it or not. That Google knows where your Wi-Fi network is, and there are databases of Wi-Fi networks. So if I come home and my phone picks up that the GPS is off, but it picks up my home network, Google knows that I'm home, whether I've got GPS on or GPS off. So knowing the MAC address of knowing the MAC address of the Wi-Fi networks around me is also a way of geolocationing. I'm not connecting to the Wi-Fi networks. I'm just knowing that I can see them and I can list the networks. By listing the networks and knowing the RSSI of each network, I can geolocation. Okay, this is the second one. Passive scan Wi-Fi. I can't connect to the Wi-Fi. I don't have a way of connecting to the Wi-Fi, but I know where I am vis-a-vis the Wi-Fi networks. Okay, and the last one is GNSS scanner. GNSS is basically GPS. GNSS, the same type of satellite geolocations. Okay, these are 3 different technologies of geolocationing. Okay, so this chip is roughly about a $7 to $10 chip, and it allows 3 methods of geolocationing using LoRa. Okay. It is a chip which I basically want to work around. Okay. We've now moved to KiCad. This is the KiCad schematic, default schematic for the chip. It's been translated from Altium. The translation didn't go overly well from Altium to KiCad. Some of the things I didn't like about the chip. Some of the things I didn't like about the way it's done. For example, this is in my grid is wrong, everything is wrong, everything needs to be sorted out to fix up the circuit, so the circuit matches the original one, and I can create a netlist. When do I know that my circuit will be, shall we say, Neman Makor? It'll be Neman Makor when I match this PCB, because I have the circuit and I have the PCB in Altium. Unfortunately, it didn't translate that well to KiCad. Once I have the circuit and a netlist which matches this board, I'm going to change this board to an STM. Okay, STM, and I'm going to be more than likely looking at, shall we say, Reltron. Here I do Reltron. Why is it not doing this? Okay. Okay. More than likely, I'm going to change to chip antennas. I'm going to be using chip antennas, not the RCA, not the antennas used. Yeah, not these, and not SMA antennas. I want to use board antennas to see exactly how good or how bad I can make it using broad antennas without going the whole hog of big external antennas. Okay. If you want something which is to be tracked via acid tracking, you don't want big external antennas. You want a small, you want a very small footprint, which is going to be battery operated. More than likely 5 to 10 years battery life. Okay. This doesn't interest anyone in Israel because it's too much of it's too real. Everyone wants you're not going to be able to have a major exit on this. And everyone's interested in a quick buck and an exit. No one's interested in doing something of any value. Such as Israel. Okay. Obviously, I'm going to have to redo this PCB with somewhat less clean up the vias. There's no reason to have all these vias here on the area where I'm going to need the STM. I'm going to need the STM here. And that's basically it. More than likely that I'm going to make it a bit thinner. If one goes back to the 3D view. The 3D view, I'm going to put my antennas one next to each other. I'm not taking out 3 different antennas in 3 different directions. For example, this is the Wi-Fi antenna. This is the GNSS antenna. And this is the LoRaWAN antenna. Okay, this area here is all area which is going to be the power supply. More than likely it'll be a bit thinner. Okay. Once again, the RF is going to be the RF stages is going to be a copy exact of this. I'm not going to change anything within this area here. I'm going to leave as is, 100%, no changes. Okay. If we go now to YouTube. Once again, LR, not RN. Okay, we're looking at YouTube. This is 2 weeks ago, the webinar, which I watched. Hands-on on this product, which is 2 weeks old. Including here was how to integrate this into my LoRaWAN setup, including my network system. Okay, if I look Exit 2 weeks ago.
A warm welcome to everyone to today's webinar, hands-on experience with LR1110, LoRaWAN transceiver with GNSS and Wi-Fi.
It's called ChirpStack.
My name is Luke from Irnas in Slovenia.
Okay, ChirpStack is my LoRaWAN network that runs on my VPS. Okay, this is an hour that anyone who's using LoRa, thinking about using this device, I advise them to go and watch this hour video. 2 months ago at the Things Network, Nicholas showed off the first view of this device. Okay, 1 month ago, Lacuna Space integrated it into their they were able to send to their satellites from the LoRa LR1110. Okay. Basically, that's where I'm at. I'm doing this for myself. More than likely, I'll do it. It's going to be a long-term project, which will be done in India after I've left Israel. I see no prospects. Thank you for your time.